Thank you. That was an excellent introduction. Also, James Dempsey and the breakpoints are just honestly pretty amazing. So I'm really excited today to talk to you about mapping and flat mapping in Swift. So I'm Neem Serra. I work at Worldwide Technology Asynchrony Labs, which is a really long name because Worldwide Technology just bought out Asynchrony Labs about a year ago. They just opened an office in New York City, so if you are interested in being a Swift developer there, I really like where I work, so please come talk to me later on. But also you can follow me at Team Neem, and we could always talk Swift, especially with cupcakes. Okay, so Swift came out like 3-ish years ago, and everyone got really excited because Swift has a lot of functional programming. So if you think about the developer hierarchy, it's like, we're mobile developers, we're pretty cool, and then there's like functional programmers who are like pretty badass, and then there are like kernel developers. Well, this is like my hierarchy. And so I want to go from being, normal mobile developer to doing some more functional programming, right? So I'm pretty excited about this. I'm like, awesome, Swift has some functional programming. I'm going to be pretty badass. I'm going to go and I'm going to talk to my friends that do Haskell and do some Scala, and I'm going to figure out how to do some functional programming. So if you don't know about functional programming, it's a specific way of programming where you try not to change the states of things and you don't have as much mutable data. So when you input something into a function, the same inputs will always produce the same outputs. So I asked my friends who do Scala, like, what should I do to learn some functional programming? And the first thing they tell me to learn about is mapping and flat mapping, which sounds awesome. So I'm listening to them explain it, and they say, okay, you need to go and learn about monads. So I do what I normally do, which is I go online and I look it up on Wikipedia. And the first thing that comes up when you look up monads on Wikipedia is this warning that tells you that you need an expert in functional programming to learn about it. They're like, okay, this is not going well to start with. And then the first couple lines say something like, in functional programming, a monad is a design pattern that defines how functions, actions, inputs, and outputs can be used together to build generic types with the following organization. 1, define a data type and how values of that data type are combined. And 2, create functions that use the data type and compose them together into actions following the rules defined in the first step. Okay, I'm going to be real. I read this like 10 times, and then I had a bottle of wine, and I read it again, and it made no sense at all. And I read a bunch of people's blogs about I'm going to explain to you monads. No, you don't actually have to learn about monads to learn about how to use mapping and flat mapping. So I'm reading this, and this is really honestly how I feel about the whole thing. And so if you think back on it, me trying to learn functional programming, I'm super overwhelmed by this. And so luckily for you today, it'll all be okay because we're going to learn about mapping and flat mapping through the use of cupcakes. And I'm really proud of these cupcakes, so don't say anything negative about them because I drew them all, okay? The middle one's my favorite one, so also if you don't like my handwriting, you're stuck for 30 minutes. Well, 25. Okay, so there's cupcakes. A box of cupcakes are represented by an array of cupcakes. Fairly straightforward. These cupcakes are all unfrosted cupcakes of diverse cake flavors. So remember, we have a lot of diversity in cupcakes. Cupcakes have 2 attributes. They obviously have cake, that's not optional, and then they have frosting, which is optional. So right now you see a frosted cupcake. And then cupcakes have 2 functions. Frosted takes a unfrosted cupcake and returns to you the same cupcake, but with frosting. And then there's a function called getFlavor, which just returns to you the string of the flavor. So fairly straightforward. And then there's frosting. The frosting class, I didn't mean to force unwrap this. As he was singing the optional song, I was like, oh shoot, I have an exclamation there. I'm really excited about frosting. That's the reason there's an exclamation there. Frosting can have optional sprinkles, which is pretty straightforward. And then there's one function called sprinkled, and it takes a frosting and it returns to you frosting with sprinkles on it. Okay, so let's talk about mapping for a little bit. The first kind of mapping that we're going to talk about is mapping over a collection, so something like an array or a dictionary. And basically, when you map over something, you loop over a collection, you take every single element out of it, and you apply some function to it, and then you get a return type. So if we had an array of cupcakes, and if I wanted to frost all of the cupcakes, I would do a for loop in the old way, and I'd say for cupcake and cupcakes, let the frosted cupcake equal cupcake.frosted, and it would take that unfrosted cupcake and it would frost it. So fairly straightforward. So I would go through every single element of this cupcake array, and I would frost them all. Now the new way would be to use mapping. And so to do this, we're going to say, let frosted cupcakes equal cupcakes.map, and then you have a closure or a function, and in this case, we're going to use the shortened syntax and do $0.0.frosted, and that will actually return to you an array of all frosted cupcakes. So it takes this array of unfrosted cupcakes, maps over it all, and frosts every single cupcake. So mapping is kind of cool. Sorry, totally hitting myself there. Mapping is pretty cool in that it will return to you a new array with all the things. So mapping doesn't always need to take in a particular type and return that same type. In the previous example, we took in a type of cupcake, we returned a type of cupcake. In this example, we're gonna get all of the cupcake flavors. So we're gonna return an array of strings. And to do that in the old way, we'd have to initialize this nice array of an empty string array. And then we'd say for cupcakes and cupcake, let cupcake flavor equal cupcake.getFlavor, fairly straightforward. And then we would append that flavor to our new array of cupcake flavors. Now the new way, when we're doing mapping, is actually a nice little one-liner. And we could just say cupcakes.map and $0, which is the shorthand for the first argument. And we just say get the flavor, and it returns to you a nice array in one line that has all of the flavors of the cupcakes. So I've been really excited about this. I probably spent more time on this slide over the rest of the talk because I wanted to name all of our cupcake flavors after Taylor Swift songs, and my life is now complete. Like I did a talk about cupcakes and Taylor Swift songs, so I'm just pretty happy in life. But basically, mapping is really nice in that it just lets you take an entire array, apply a function to it, and get back an array with some new type of thing. In this case, it would be all strings. So if we just compare that, you'll see that we have a 4-line thing versus a 1-line thing. And if you're doing something fairly straightforward like this, you'd like using mapping. So what actually happens under the hood of mapping? I showed you the very last line, which is like the very, very short, simple way of doing this. But what actually happens in mapping is the first thing in mapping is you actually send in a closure. A closure is the same basically as a function, and you'll see on the very top example that we're sending in this function that the first argument is a cupcake of type cupcake, and it returns to you something of type cupcake. So, and then you actually do stuff on the inside. It's very similar to a lot of block syntax and other things like that, but Swift is pretty smart. So it knows that, hey, I'm doing this frosted method on a cupcake. I know you're returning a type of cupcake, so you don't actually have to do the arrow and cupcake and tell it what type you're returning. So you could drop that, and you'll see that in the second example. But then, again, Swift, again, is really smart. So it's like, I know your arrays are of type cupcake. You don't have to tell me that. So you could drop the colon cupcake where you're telling me the type. And you could just say you're going to do something over everything in the array. So just cupcake in cupcake.frosted. But also, we have this nice short syntax for every single argument that you pass in. The first argument you pass in could be $0. The second argument is $1. So that's where we get this $0.0.frosted in the very shortened way of showing mapping. People like using different ways, any of the 4 ways, basically, depending on how readable you want it, how complicated it is. If the stuff on the inside of the closure is pretty long and cumbersome, you might want to be more explicit about it. But if it's pretty short and it's just a 1-line thing, you could do the last line. Okay, so just going over mapping. So mapping takes a single argument of a closure. The closure takes an element from the collection and returns the result. And then the results are all aggregated together into an array of the closure return type. If you wanted to map over a dictionary, you would do the same thing. In this case, the first argument is the key, the second argument is the value. So if I wanted to get an array of all of the values, I would just map $1, and it would return to me an array of all of the cupcake types. And you'll actually see it's not in the same order because dictionaries are unordered. Okay, so mapping on optionals is actually slightly different than mapping on arrays. And so say I had something that was the number of cupcakes and it was an optional integer and it was equal to 0. If I wanted to say add 2 cupcakes to it, I would try to do number of cupcakes plus 2. Now what happens is you get something that says error. You basically can't add an optional to an actual integer without unwrapping it. Mapping is pretty nice in that it will let you, if you send something into a map, it will unwrap it on the inside. It will turn it into an actual integer, and then you can add 2 to it, and then it will rewrap it back in as an optional and return it back to you. So you can do something like this, where you send in something that's optional, it will unwrap it, do whatever function you want on it, and then it will send it back to you and rewrap it as optional. Okay, cool. So now we're going to move into flat mapping. Flat mapping has a lot of cool things and it's kind of complicated, so bear with me. We're going to have a lot of examples here. So flat mapping basically flattens a container and maps over an array. And generally, people like saying that flat mapping sees things in one less dimension. Okay, so if I had 2 cupcake boxes, so if I had an array that had 2 arrays on the inside of it, if I flat map this, what would end up happening is that it actually takes all of the cupcakes out of the array and returns back one array. So it kind of takes one dimension of the arrays out and it combines it into one array, which is pretty cool. So anytime that you have nested arrays, it will take one layer of nesting out. The old way of doing that, if you had nested arrays, you would have to do a for loop over the arrays, and then you would have to add it into a new array to combine them into arrays. So this is kind of nicer in that it's a one-liner. So flat mapping is weird, right? I showed you this example. It was nice. It went and it smushed it all into one array, but people don't really understand what the first argument is. And so hopefully this will kind of make a little more sense. So what is the first argument in that? It is actually each array. So when it is flat mapping, it sends in the first array, and then it sends in the second array, and it does some function to it. And then afterwards, it removes the layer of nesting and returns back just one array instead of having your nested arrays. So if I wanted to do something where I wanted to double all of the numbers in this, I would try to do something like cupcake numbers.flatmap, first argument times 2. But if you remember, I said that the first argument's actually an array, and so you can't really multiply an array times 2. And so you'll end up getting an error. And if you wanted to do something like this, you would have to do something where you flat map it. The first argument is an array, and then you would have to map the inside of the array and try to double the number. And then when you get back, returned is partly off the screen. So kind of sucks for you, but you can kind of understand that flat mapping would return something that has all of the numbers in one array. If you swap that first flat map into a map, you would actually get something that had both arrays still. And so it's kind of nice. You'll see that flat mapping just really takes out a nested layer of arrays. Flat mapping is also specifically overloaded to deal with optionals. So this is where flat mapping becomes super powerful in my mind, and I really love it. So if you had something where you had a box of cupcakes and some of the slots for the cupcakes had nil cupcakes in it, there weren't any cupcakes, I already ate the cupcakes, so you had this box of 4 cupcakes and there are only 2 real cupcakes in there. If you were to map over this, you would get back an array that would give you optional cupcake, nil, optional cupcake, nil. Now, if you were to do a flat map on this, you would actually get back an array with just the cupcakes. The cupcakes wouldn't be of type optional anymore. They would be real cupcakes and no nils. So flat mapping will take out all nils in arrays for you, which is pretty awesome. So the old way of doing that would be something where I say, for cupcake and cupcakes, if let cupcake equals cupcake, then real cupcakes append the cupcake. So if you kind of look at the difference between the two, you have a one-liner that really takes out all of the nils versus another 4-liner that goes through each of the cupcakes and decides if it's nil or not and then appends it to a new array. So what happens if you have nested arrays that are optional cupcakes? So you have some nils in the optional cupcake array. So the first flat map will actually take out the nesting of the arrays, and then the second flat map will actually take out all of the nils. So flat map will kind of take out the outside layer first and then keep going inside. And so the first outside layer was the nested arrays, and then the next layer is going to be the optionals. And we don't have any more layers, so I'm not going to go into that. So why do we really like mapping and flat mapping? I really like it because it gives you visually explicit chaining, and you'll kind of get more of an idea of that when I give you this next example. So say I had 2 boxes of cupcakes, similar to what we had before, the optional cupcake boxes. I want to remove all the nil cupcakes, I want to frost all of these cupcakes, and then I want to add sprinkles. So basically what I would do if I were actually making cupcakes right now. So we'll start with 2 boxes of cupcakes that may or may not have some nils in there, and cupcakes will be an array of cupcakes. So the first thing I would do is flat map it, and that would combine the 2 boxes of cupcakes into one box. The next thing I would do is flat map it again to remove all of the nils. We would flat map it again to frost all of the cupcakes. And then I would try to get I would get the frosting object so that I could add sprinkles to it. So that's where I'm doing this next flat map to get all of the frostings. And then I would be able to map over all of the frostings and add sprinkles to it. And then deliciousness would end up actually giving you an array of just the frostings with sprinkles on it. If I wanted to actually see the cupcakes, I would have to print the cupcakes, and then you would get the entire object back. But if you remember the way that we change all of this, the return type of the very last map is of type frosting. Okay, so that was like a fairly straightforward example. We'll go into a more in-depth example of, say I have a little kid, and the little kid wants me to have a box of cupcakes that's frosted. And I'm with one of my friends who's on a diet for some reason, doesn't want frosting on their cupcakes. So I have 2 boxes. I only want to frost one of the box of cupcakes. I'm trying to hold on to this kid, so I want all my cupcakes to be in one box. So I only have to hold one box and hold the kid in the other hand. I want all my nil cupcakes removed from it so I could have this tiny box. The kid in the middle of all this, while the baker's trying to figure out all of this stuff, wants me to add sprinkles to all of the cupcakes. And then at the very end, I need to figure out how many cupcakes do I have with frosting and sprinkles so I can figure out what the upcharge is at the bakery. So the first thing I would do, I would take the first box, and I would only frost the first box. You get something where the first box now has frosting, cool. We're going to combine our 2 boxes again. So now you'll see on the first flat map, we've combined our box. So we have 2 frosted cupcakes, 4 unfrosted cupcakes. Flat map it again to remove the nils. And then now we're gonna do a flat map to only get back things that have frosting. And so when we do this flat map, it removes every single cupcake and that doesn't have frosting, because all of those would return nil for their frosting. So now you only get the 2 frosting objects that actually exist. And then we could add sprinkles to that. And then at the very end, we could even chain a dot count onto this, which is pretty excellent. And then, so now our cupcake count would return to us 2 for 2 sprinkled cupcakes. Now, if I were to do that normally without mapping and flat mapping, you actually get this whole mess of code. I had to rewrite this like 4 times because I kept missing pieces of it. But basically, you would frost the first box of cupcakes, you would then combine the 2 boxes of cupcakes, and then you would see if the cupcake existed. If the cupcake existed, then you would add it to a new array, and if that cupcake had frosting, then you would add sprinkles to it. This code is actually doing the same exact thing. It's just a lot more cumbersome and a lot harder to read. So that's kind of the big use of why we use flat mapping and mapping, so that you could see just very simply like, okay, we are chaining together these 4 or 5 functions and then getting something back. So if you do, a little comparison, you could see that this is actually a lot shorter. So we have a couple other examples of why you would want to use flat mapping or mapping. So say I was getting some data back from a server. My server team is not as good as I want them to be, so they're giving me back a lot of weird data. I want to turn everything into integers. So I would do a flat map on this array, and any string that could be turned into an integer would be returned. So 1 and 5 would be returned, and anything that couldn't be turned into an integer would just be dropped and not put in the array. Similarly, if I wanted to, say, add an optional subview, we could do a map on that, and if the optional subview didn't exist, nothing would happen. The old way would be doing something like if let optional view equals optional view, then view.add subview. This just makes it kind of simple and just in a 1 line of like, well, do this thing if it exists. If it doesn't exist, then just kind of drop it on the floor. Similarly, you could do the same thing with string interpolation. I like using mapping better in this case, just because I like having the happy case of there are however many cupcakes in the box first, versus having something where I'm like, okay, is the number of cupcakes nil? If it is, then do this thing, otherwise do my happy case. It just makes it a little more readable in my mind. And then lastly, there's some magic going on with how we could do some shortcuts on initialization of methods. So an initialization method is basically a type method, which is a function which could be used as a closure in this. And so we can actually do some shortcuts here. So if I wanted to, say, take all of these cupcake counts and then turn them, all of these integers and turn them into strings, the old way I would do that is mapping it and then making a string and inputting the number itself. What you can do is you can use this shortcut method and do the first thing where you just, instead of having an actual closure in parentheses, in brackets and whatever, you could just simply put parentheses string.init, and that knows that you are basically trying to initialize with the first thing in the array. And this is kind of complicated, so there are office hours after the coffee break, and we could totally talk about this more and kind of go more into detail about why you could do both of these things and they do the exact same thing. And I kind of think it's magical. But what it's really, really magical is if you have objects that can fail on initialization. So if you're sending in a dictionary to something and if the dictionary doesn't have an ID, then you can't make an object, something like that. Those kinds of things, you can actually do a flat map on it and you could try, and if it fails on initialization, then you could filter those objects out. So if I were doing something where I had all of these strings of types and there were cupcake icons, if I did a flat map and tried to make a UI image out of it and these images didn't exist, mapping would give me something that said nil, nil. Flat mapping would actually take out all of the nils. And so if you have objects from your server, you got all these dictionaries and they're not creating real objects, you would find out very easily, and they would just be dropped from your array. And then in general, there's a whole lot of other tricks. You can get the index path of a cell, index of an element in an array. You could start using mapping and flat mapping to step up your functional game. And basically, it's pretty magical in my mind. It makes your code a lot easier and simpler to use. And that's it. I'm done. Thank you.